It says if you're given, and they're telling you the relationship, but by now you've learned these relationships because this is kind of like side splitter. But we don't have any parallel markings, so we can't be sure of that. They're telling us that Rn is proportional to Rp as Qm to Ql. So you're going to write out a proportion. And you're going to have Rn to Rp. Rn is 4. 4 is to x. And again, this is number 7. 4 is to x is 6 is to 10. Okay, you can reduce this 3/5, and that makes it easier. You got 3x equals 20. So x is 20/3. Or you can go ahead and multiply it through and you get 40 and 6x, which is still going to be 20/3. All right, number 8, you're given CD is to DB as CE is to EA. So CD is the one we're looking for, and we have X, CD. X is to 5 as 10 is to 4. 4 times x is 4x, and 5 times 10 is 50. Or you could reduce this and you got 5 halves and you'd get 25, but you're still going to wind up with the same thing because you've got 50 over 4, which is the same thing as 25 halves. Of course, if you're using the calculator, you're going to come up with 12.5. I'm tempted to say questions. Anybody have questions? Okay, using similar polygons. Looking at number 9, it says in exercises 9 and 10, determine whether the polygons are similar. If they are, write a similarity statement. There's some problems with these similarity statements because people don't always remember what it means. It's not that it's hard to do, they just forget what it means. Okay, we have 2 rectangles here, and we're comparing the same sides. So we're going to take the long sides first, and we're going to say 12 over 9. 12 over 9 is the lengths compared, and the widths then would be 8 over 6. Now you need to put these in lowest terms to be able to tell if it is proportional. So in lowest terms, we're dividing by 3, we get 4 over 3. And dividing here by 2, we get 4 over 3. So they are similar. So to write that they're similar, we're going to make sure that we match up the lengths and the widths together. So we're going to say A, B, C, D. A, B, C, D is similar to, now AB is a long side, so GH or EFGH, we could do it either way. EFGH. Just make sure that you're matching up your vertices together correctly. All right, looking at the triangle, when you're working with triangles, you've got to use a strategy here. You want to do the shortest side and the longest sides first so that you don't get your numbers mixed up. So let's start with the shortest sides. The shortest side of the big triangle is 15, and the shortest side of the little triangle is 6. So we have 15 to 6, dividing by 3, we get 5 halves. And then the longest side of the large triangle is 25, and the shorter side, the longest side of the small triangle is 10. So we get 25 to 10, and dividing by 5, we get 5 halves. And then we're going to look at the medium-sized side, which is 20 and 8. So 20 to 8, and dividing by 4, we get 5 halves again. So the triangles are similar. Now you need a strategy for making sure that you write these correctly. So we're just going to start with the shortest side and work around from the short to the medium to the long. So looking at the first triangle, the short side is 15. So we're going to say Y, Z, X. Y, Z, X is similar to, same thing on the small triangle. We're going to start with the small side, working towards the medium side. Q, R, P. Q, R, P. And I want to say, any questions? Two similar posters have a scale factor of 4 to 5. The large poster's perimeter is 85 inches. Find the small poster's perimeter. All right, now this is kind of a trick question because you're tempted to find the sides. But remember that the perimeters of figures are proportional in the same way as the sides. Since the proportion is 4 to 5, all you really need to do here is write your ratio of 4 to 5. Now which number goes with the small one? The small one would be the small number, 4 to 5. And it says that the large rectangle's perimeter is 85 inches. So you're going to match up the perimeter of the large figure. Okay, so 4 times 85. I'm not even going to try to do that in my head. There are days you do that stuff and there are days you refrain. Equals 5x, and dividing by 5, we get x equals 68. All right, it says use the angle. This is on page 420, number 12. Says use the angle similarity postulate to show that the triangles are similar. So you need to look at your angles, find two angles, and remember, if you have two angles that are congruent, not similar but congruent, be careful about that because similar figures have congruent angles and proportional sides, and you can't call the sides similar because all sides would be similar since they're all the same shape. Similar means the same shape. Okay, so looking at number 12, we have two angles that are 35 degrees, so that's easy. You can say, well, angle Q is congruent to angle T. Well, that's easy, but that's only one angle. So you look at the figure and you remember vertical angles, and you say, oh yeah, QSR is also congruent to UST. Okay, so by angle similarity, the figures are similar. Okay, and if we were to write a similarity statement, we would want to start with Q and move towards S, because we know that at S is where two are congruent. So we have QSR. It doesn't ask us to do this, but we're just going to do it because we can. QSR is congruent to TSU. Okay? All right, the next one, we have a 30-degree angle and a 60-degree angle labeled. So you may think, well, maybe they're not congruent. But when you look at this and you have a 60-degree angle and a right angle, and then on the small one, you have a 30-degree angle and a right angle, then you're going to say, well, what's the last angle? Well, 30 plus 90 is 120. And when you subtract that from 180 degrees, you get 60 degrees. So you know the last angle is 60 degrees. 60 plus 90 is 150. And so you know that this one is also 30 degrees. So now we have by angle, we have angle C is congruent to angle F. And then you only need one other angle, so you could say either angle A is congruent to angle D. Now remember, when you're looking at similar figures, the angles are congruent and the sides are proportional. Okay, now it says prove these triangles are similar by side, 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 or side, angle, side. All right, so we're going to look at this one and see what